Hello everyone! Today we're going to talk about how you can identify a binomial setting in a problem. Often on the AP exam, you're given a word problem but not told if it's normal, binomial, or geometric distribution. Luckily, we can use the acronym BINS to help us figure out if it's a binomial setting.
The B in BINS stands for binary. Binary means that for our random variable, there's only two outcomes. For instance, when flipping a coin, you can only have heads or tails. Often, we refer to these two outcomes as a success or a failure. So if I'm trying to find the probability that I will get a heads 3 times out of 10, heads would be considered the success, where tails would be considered the failure. The I in BINS stands for independent. Often we have independent trials that we're working with, such as flipping a coin. Just because I make a tails on the first flip, it has no bearing on whether or not I'm going to make a heads or tails on the second flip. They're independent. The problem comes when we're sampling, specifically sampling without replacement, such as picking cards out of a deck and not putting them back in. When that happens, we have to make sure that we're checking the 10% condition. Remember, the 10% condition is just a way of checking that the sample size we're taking is small compared to the size of our population, so that the minute differences in the probabilities don't affect our overall answer. The N in BINS just stands for number of trials. What that means is there's actually a set number of trials. So in the problem, it will specifically tell you that you're going to take 30 free throw shots, or you're going to flip a coin 12 times. It has to be given to you. Finally, the S in BINS stands for same probability. That means the same probability of success. In other words, the probability of success never changes. For instance, when I flip a coin, I know I have a 50-50 chance every time that I will get heads or tails.
Now that we know that BINS stands for binary, independent, number of trials, and same probability, let's put our knowledge to the test with a little example.
Here's an example similar to one you might encounter on the AP exam. I'd like you to pause the video, read through it, give yourself a minute or two to go through BINS, and then unpause and check your work. Now that you've had a moment to work it out, let's go through BINS together. Remember, B means binary, so in this situation, are there only two outcomes? Well, if X is the number of aces, I'm either going to observe something that's an ace or not an ace. So in this case, yes, it is binary. For our second part, independent, when I read the problem, it does tell me to put the card back in the deck. So even though I'm sampling, I'm doing it with replacement. Therefore, this is independent. Next, the N. Do I have a set number of trials? Well, repeat this process 10 times. So N equals 10, yes. And then finally, do I have the same probability of success every time? I'm trying to see aces. There's 52 cards in a deck and 4 of them are aces. So if I'm putting the card back every time, I still have 52 cards in every trial. Therefore, my probability of success is always going to be 4 out of 52. So yes, since all 4 of my criteria worked, this is a binomial setting and it would be appropriate for me to use a binomial distribution.